Hey, fellow explorers. Imagine this, an endless supply of clean energy from the sun, 24/7, no clouds, no nighttime interruptions, and no pollution. Sounds like something out of a sci-fi movie, right? But what if I told you this idea could actually solve the energy crisis? Welcome to today's deep dive into the world of space-based solar power, SBSP, a game-changing technology that could forever alter how we power the planet. Stick around as we explore how this concept works, the challenges it faces, and how it might be the key to saving our planet's future. Let's get into it. What is space-based solar power? Basic concept. So, how does space-based solar power work? Imagine a solar panel. But instead of being stuck on Earth, we place it in space, where the sun shines continuously without interference from weather or the Earth's rotation. A solar satellite up in orbit would gather energy and transmit it to Earth using microwave or laser beams. Think about it. No more cloudy days, no more energy losses at night. It's constant, clean, and reliable. How does it get back to Earth? That energy collected by the satellite isn't stored. It's transmitted wirelessly. Using technologies like microwave transmission or laser beams, energy is directed to rectennas, special receiving stations on Earth. These stations then convert the energy back into electricity, which can power homes, factories, and even whole cities. Why is SBSP so exciting? 24/7 energy. One of the biggest advantages of SBSP is that it offers continuous energy generation. Right now, solar panels on Earth only work when the sun's shining. But with solar panels in space, they could be collecting power all day, every day, 24 hours, 7 days a week. No interruptions, no weather delays. This could be the key to solving energy shortages around the world. Clean energy. Unlike fossil fuels, SBSP produces energy with zero emissions. By using solar energy directly from space, we can significantly reduce our dependence on polluting coal, oil, and natural gas. This means cleaner air and a healthier planet, all while meeting the energy demands of our growing global population. Global coverage. Another major perk is that SBSP could deliver energy to any part of the world, even to remote areas, isolated islands, or disaster-stricken regions where it's tough to build traditional power infrastructure. This could be a game changer for developing countries, providing them with affordable, sustainable electricity. How could SBSP solve the energy crisis? The growing energy demand. As we continue to grow as a global population, the demand for energy is skyrocketing. By 2050, the world will need at least 50% more energy than it consumes today. Traditional energy sources like coal and oil are not only unsustainable but also wreak havoc on our planet. We need new renewable ways to keep up with this demand without destroying the environment. A constant supply of power, that's where SBSP comes in. Because these solar satellites are orbiting above the Earth, they're always in the sunlight. With solar energy collected from space, we could have a constant supply of energy, day or night, rain or shine. Imagine how much more stable our global energy grid would be if we could depend on uninterrupted power. Fighting climate change. Let's talk about climate change for a second. The impact of burning fossil fuels is felt worldwide, from rising sea levels to extreme weather patterns. By shifting to space-based solar power, we could dramatically reduce greenhouse gas emissions, helping slow down global warming and protecting future generations. Challenges of space-based solar power, high costs of launching. Okay, it sounds amazing, right? But there are some big challenges that need to be overcome. First up, cost. Launching things into space is expensive. Building and launching a giant solar satellite into space would cost billions of dollars. Right now, the cost of putting something in orbit is still a huge barrier, but reusable rockets, like those from SpaceX, could help drive prices down in the coming years. Building in space. Next, we need to build the infrastructure in space. Imagine the complexity of assembling massive solar panels in zero gravity. But with the advancement of robotics, AI, and space construction techniques, this challenge is not out of reach. These satellites would need to be self-assembling or built with robots to ensure they're strong and stable enough to collect the energy we need. Energy transmission efficiency. Another challenge lies in the transmission of energy from space to Earth. We're talking about sending microwave beams or laser beams through Earth's atmosphere to ground stations. How do we make sure that energy doesn't get lost in the process? Researchers are working on improving transmission technologies, but it's still one of the biggest hurdles. Safety and environmental concerns, microwave beams and safety. You may be wondering, could there be any health risks? After all, we're talking about sending high-powered microwave beams through Earth's atmosphere. However, experts argue that the energy levels would be no more dangerous than the energy emitted from your microwave oven or Wi-Fi. The beams would be carefully controlled to ensure they're safe for humans, animals, and even aircraft. Space debris. There's also the concern of space debris. Building massive satellites in space could increase the risk of collisions with existing satellites or even create new debris. But space agencies are already working on ways to mitigate these risks and ensure that space remains clear for future missions. The future of space-based solar power, who's developing it? So is SBSP just a dream, or is it something we're really working on? Well, the good news is it's already happening. China is already planning to launch a test satellite by 2030, and NASA's been developing prototypes for years through the SPS Alpha project. In 2023, Caltech successfully launched the first space-based solar test that demonstrated wireless energy transmission in space. And Japan is on track for a commercial space solar station by the 2040s. Could we see it in our lifetime? As space technology continues to evolve, the possibility of space-based solar becoming a mainstream energy source seems more and more likely. By the middle of the century, we could be seeing massive solar satellites orbiting Earth, providing the energy we need to power a sustainable future. Conclusion. So there you have it. Space-based solar power is no longer just a far-off idea. It could be the future of energy, helping us tackle the global energy crisis, reduce carbon emissions, and combat climate change. We may be years away from making it happen, but the progress is real. What do you think? Could SBSP really save the world? Drop your thoughts in the comments below, and let's talk about this incredible technology. Subscribe. If you enjoyed this deep dive into the future of energy, don't forget to like, share, and subscribe for more amazing content on space, science, and the tech shaping our future. Thanks for watching.